Okay, section 1.8 is on combinations of functions and something called composite functions. Okay. So, to understand when you would actually use something like this in the real world, how many of you have an iPod? 1, 2, so forth. How many of you had an iPod that you used frequently a few years ago? Okay, I see a lot more hands, okay? What happened? Why don't you have them now? You have an iPhone, okay? So that was the concern when iPod and iPhone were introduced, is that it would cannibalize, especially the iPod Touch, would not be as frequently purchased and so on. So that's a concern that you have as a company. If you introduce a new product, will it completely wipe out the previous product? And if it does, will I still be growing? Make sense? So here's a graph of the Apple iPhone sales, fiscal sales in years from 2007 to 2014. Remember, iPod has been around longer. It had the little wheel, click wheel, and so forth. Then the iPod Touch and the iPhone came out at the same time. So here's your iPod sales, and I have times dating back from 2006, 2007, and so on. And yes, when the iPhone was introduced, notice what started to happen. Decrease, okay? So iPhone increasing function, iPod decreasing. It stayed stable for a little while, and then it gradually started to taper off. Okay? So let's see what happens if we actually take those points, and I'll show you how to do this on your graphing calculator, I promise. I'm waiting for more of us to have graphing calculators. But if we take those points and we put them into a graphing calculator or a program like Desmos.com, you can see the blue line is the equation of the iPod sales. Definitely tapering off. Definitely a negative slope, right? And we're seeing it decreasing, but not as sharply as we're increasing on the phone. So does Apple have anything to worry about here? No, probably not. Well, let's find out for sure. But this is the equation of best fit, or the line of best fit, the oranges, of the iPhone sales. Okay? What we're going to be doing today is combining those two functions. Okay? If I take f of x, which is the iPhone sales, and I add it to g of x, which is the iPod sales, I should get a combination of iPhone and iPod sales, right? Make sense? So what do you think is going to look like when I add these two equations up? I take a line, I add a line, I'm going to get a y equals mx plus b, a linear equation, right? Okay. And it won't be as steep as 26.38 because this one's falling by 5.5. And then we'll have a different value for our b. Okay, so when I combine those two, the red line is our combined function of 20.81x plus 21.485. And you can see absolutely sales for Apple, iPhone, iPod combination is very healthy. Okay, so far so good? So that's the general gist of when you would use what we're going to talk about today. But the key here is that your domains have to be overlapping in order to make this make sense. Okay, would it make sense for me to put in values of 2001 when iPod existed but iPhone did not exist? No. Okay, we had to start with 2007 because that's when the iPhone was introduced, if we wanted to make an accurate depiction of what happens when we combine these two graphs. Make sense? Okay, so arithmetic combination of functions says that if we have two functions, f and g, and they have overlapping domains, okay, they're x values, they have x values in common, Then for all common x values in both domains, this is going to be the notation. The combined f plus g of x, the combined function, simply means that you take the f of x and you add it to the g of x and you combine like terms. If x is squared, you combine your x squareds. If you have plain old x's, you combine those. If you have constants, you combine those. If you have a function f of x and g of x and you take f of x minus g of x, then what you're doing is you're taking the original f of x and subtracting off any g of x that's there. And you have to make sure that you distribute your negative all the way across g of x. Fg of x means you're taking your original f of x and you're multiplying it by that g of x function. And then finally, f over g of x means take your original f of x and you divide it by your g of x, provided that g of x is not equal to 0. You have to further restrict that domain. Anything that would make the denominator 0 is off limits. Everybody good? Not yet. They're going to ask you. Yeah, they're going to say, given this, and I'll show you an example, given this f of x and this g of x, tell me what f plus g of x is going to be. And you add them up. Okay? Or tell me what f times g of x is going to be, and you multiply the two together. So, but in the real world, how would we know what we would be doing? Well, if I had total iPad sales, right, as a function, and then I had the function that was the iPod mini sales, iPad mini sales, and I wanted to know how many full-size ones they did, then I would take my total sales minus my mini sales to figure out what my full-size sales would be. Okay? So it just depends on what functions you have. Okay, so here we go. So we're given two functions. F of x is 2x minus 5, and g of x is 2 minus x. They're going to ask you to take f plus g, arithmetically combine them by adding them, of x. So f of x is 2x minus 5. I'm adding it to g of x, which is 2 minus x. Combining like terms, 2x and x, a negative x is a positive 1x. Negative 5 and 2 is negative 3. So f plus g of x results in x minus 3. What do I do if I want f minus g of x? It says to take f and subtract off g. So 2x minus 5. I'm going to take away all of g. So the only easy mistake that you can make here is to not distribute with your negative. 2x minus 5 minus 2 plus x is going to get me 3x minus 7. After some of the work you've been doing, this seems too easy, doesn't it? Okay. F times g of x says to take 2x minus 5 and take it times 2 minus x. But we're not finished. We need to simplify that. So what do I have to do? Distribute, FOIL. 2x times 2, 2x times a negative x, negative 5 times 2, and negative 5 times x. Combining our like terms, we get a negative 2x squared plus 4x plus 5x is plus 9x. And my last term will be a negative 10. Okay. F divided by g, 2x minus 5 over 2 minus x. But I have a special thing I have to worry about here. And what is that? Denominator can't be 0. What would make the denominator 0? X is 2. So now my domain is changing. This was all real numbers before, right? But now my domain has to change to be negative infinity to 2, but not including 2, and 2 to infinity. Okay. Or all real numbers such that x is not equal to 2. Two different ways to say the same thing. Now, these were just saying combine the functions and simplify. What do you think we're going to be doing when we have to do f plus g of 5? Simplify it and plug in 5. Exactly. So before we found that f plus g was x minus 3, right? If I plug in 5, what is f plus g of 5 going to be? Yeah. Plug it in. 5 minus 3, 2. I could ask you for f minus g of 10. And you plug in 10 to whatever you found out for f minus g, everywhere you see x's. Okay? No worries, everybody's okay. All right, the next one then is a composite function, a composition of functions. Okay, so the other one we were just combining them. Composition of a function f with a function g is written as f composed with g of x. This is a new symbol for you. Looks like we're writing the word fog, which we had plenty of this morning, right? But it's actually the composed with symbol. And what that is saying is that you take g of x, and everywhere you have an x and f, you plug in g of x. It's like putting a function into a function, substituting that function into x in the other function. Yes. Because g of x is this guy, and then we're composing it, we're putting it in place of any x's that we have in f. Okay. So we would first find the domains. If we have f and g, f of x is x squared minus 9, and g of x is the square root of 9 minus x squared. We have to find the domains to ensure that they're overlapping, and we have to be careful to restrict those domains. The final function has to be restricted by those original domains, because if they didn't exist to begin with, they shouldn't exist when we compose them together. Okay. So all this is saying is if I want to find f composed with g, I need to take g, it's supposed to be an equal sign, my fault, and I'm supposed to plug it into x, everywhere there is an x in f. But let's start with our domain. What is this function? What kind of parent function does it have? X squared is a parabola shifted 9 units to the down because it's not within the parentheses. Okay? Do we have a restriction on the domain here? No. All real numbers work. We can put anything in there. Okay? But what about this one? 9 minus x squared under the radical, a square root of. Can we take square roots of all numbers? Not negative ones in our real number system. Okay? So we can't take square roots of negative numbers. That means that we have to make this be positive. So what's going to make the expression under the radical positive? Is it okay if it's 0? If x is 0? Okay, x is 1, x is 2, or negative 2. What about x is 3? Is still okay, or are we having problems there? Anything less than 3. So we can't be bigger than 3, and we can't be smaller than, the whole thing can't be smaller than 0. Does negative 3 work? Negative 3 works, right? Does negative 4 work? No, because we get 16. 9 minus 16 is going to give us a negative 5, and we can't take the square root of a negative 5. So x has to be between, but including, negative 3 to 3. And again, if we want to write that in our notation with intervals, we can actually include negative 3 to 3. And by using a square bracket instead of an open bracket, it means it can be those. It can touch those. Okay? So we're going to take everything in G and put it into any x's that we see in F. So when we do that, we will have F composed with G will be x, sorry, x is being squared, right? So this is going to be the square root of 9 minus x squared minus 9, where this is this. And all we've done is plug the square root of 9 minus x squared into that spot. When we square the square root of 9 minus x squared, what do we get? 9 minus x squared. They're inverses of each other, right? So they take care of each other. And then we have this extra minus 9 hanging out. 9's will cancel. So f composed with g of x is going to be negative x squared. But again, because my original function was limited to between negative 3 and 3, including negative 3 and 3, my composite function, my composed function, has to be the same domain for all x between negative 3 and 3. Okay? Just like not having iPod sales from 1970. Didn't exist back then. Okay? Wasn't part of the domain. Yep, you have to include, especially if they ask you for the domain of your composed function. But kind of keep that in the back of your mind the whole time. Okay? Everybody okay with composite functions? Or would you like to see one more example? I'm okay either way. I have another one prepared, but we don't have to do it. Okay, all we're doing is plugging in whatever we see in G and putting it into F. or to the x's of f. Everybody good? Or you want to see another one? Do one more? Okay. So we have x squared plus 2x and 2 plus x as our two functions. Okay? F composed with g says take whatever is in g and put it in every place that you see x. Thank you for speaking up, because there are probably 4 other people that were thinking, I hope she does another example. Or more. Probably more than 4. Okay? All right, so we're going to take this 2x plus 1 and square it. And we're going to add a 2 times that 2x plus 1. Now don't take the algebra 2 way of doing this and say this is 4x squared plus 1, because what would we be missing? Two x plus 1 squared, quantity squared, means take 2x plus 1 times 2x plus 1, right? So don't try to take the shortcut and just tell me it's 4x squared plus 1, because what are we missing? Another 4x. Don't forget your outsides and insides. Okay, and then we have a 2 to be taken times what was g. So 4x plus 2. So 4x squared plus 8x plus 3 is our new composed function. No restrictions on the domain to begin with. This is a parabola. This is a line. All real numbers, so no restrictions on the domain here. Okay. What if they ask you to go the opposite way? Find g composed with f. Absolutely. Plug in the f for any x's that we see in g. So this is saying take all of this and put it in everywhere you see an x over here. So g composed with g composed with f is going to be 2 times this x squared plus 2x plus 1 more. Then simplify. And we can't combine anything else, so we're done. Okay. Comfortable, confident with that? Next one, last one. Decomposing a function. So we compose them. Now we're going to decompose them. There's more than one right answer to this, but to me there's an obvious one. We want to find two functions, g of x and f of x, or f of x and g of x, such that when we compose them, we get this h of x. Does anybody have any suggestions? What could f of x be and what could g of x be, so that when we take g of x and we put it in for every x in f, we get that? It's mind bending. Let me give you a hint. What if we do 2 minus x squared as my g of x? Yes, sir. Exactly. Does everybody see why? It changes. Yep. We'll have lots of different h's of x's, and we'll ask you what it could be. If h of x is x minus 2 squared plus 5, what could be my g? X minus 2, and it's possible. So x minus 2, then what would f have to be? X squared plus 5. So the easy way to do it is find what's grouped and let that be your g, and then adjust the f accordingly. Make sense? Okay. All right, assignment. Page 81, giving you lots of odds today so that you can check your work. Okay. 5 through 11 odd, 13 to 23 odd. Should have written 31 through 37 odd, 40, 42, and 47 through 51 odd. And you're welcome to take a picture. Okay. Assignments on systree.com. This recording will be on systree.com. Go to pre-calculus, click on today's date in the calendar.